Good.
No, I'm like, yeah, I don't have a complaint, actually.
Okay.
Why so many questions?
For practice. For practice.
They
Yeah.
actually help.
Yeah.
Oh, I think
Mhm.
this, cheat sheet, I don't know, you accept it? Me and ChatGPT, I
You
mean,
didn't you didn't like mine?
I liked it, but it wasn't including the most basic things, which are
What
these,
do you mean?
like these lines.
This stuff was there, but in a more simplified form.
Sure,
Yeah.
it's good for me too.
Yeah. So it's here. It's this stuff. That's literally this whole page. And then this was most of the test.
Oh, no, that I figured out.
Yeah. And that was it.
No problem with the exponents, honestly. My problem is when you put more than one letter, one thing, like, yeah.
But it's all the same thing.
Okay.
Even though it's more than one letter, it's the
Should have
same.
put the prime number.
Right? That wasn't there. That's fair enough. I mean, some of that stuff, like with the arithmetic, was kind of negated because you had the calculator,
Yeah.
you know? Like,
No,
yeah.
I'm bad at very, very bad.
As long as you could think through it, you'll be all right.
That's-
Yeah. Like there was one question, like when I was doing it myself, there was one question that I needed the calculator, and the rest of it was easy. And when I say I needed the calculator, like I didn't really need it. I could have done something like this, like like long multiplication, and I could have gone through and done that. But yeah, that was the only part, you know. Yeah.
What are we doing
All
today?
right. So, since there's no questions, we're going into factoring. I mean, we kind of already spoke about factoring. We did like greatest common factor, that kind of stuff, right? Mm-hmm. So now we're gonna take it up a notch. Always, whenever you have a function in front of you, you want to first start off with looking for a greatest common factor. But after you finish with the greatest common factor, then we have to look at other ways that we can factor. Now, last time we spoke about factor by grouping. So that's when you have four or more terms, right? You draw the line down the middle, greatest common factor on the left, greatest common factor on the right, boom, boom, and then you have your two factors, right? Today, we're going to switch it up. So now, instead of having four terms, we're going to have three terms. All right. Now, this is a little bit more complicated, right? Because not only do we have variables in the beginning of this expression, we have variables at the end. Your answer, very simply, is going to look like this. You're going to have two binomial terms being multiplied together to give you out this quadratic expression. You see how right here is r squared? So that means I need two r's to get r squared. So there's going to be a r here and an R here, right? That's me trying to write an R. Over here, you see how there's two S's, there's S squared, right? That means that there's going to be an S here and an S here, right? The only thing I have to figure out is what's going to be the signs of the numbers in the middle and the numbers in the middle, right? So now, first thing I want you to notice, right? My C term here, the last term, that's negative, right? So what does that tell me if that's negative? That means that one of these middle numbers has to be positive and one has to be negative. If the C term was positive, then that means that either both of those terms are negative or both of those terms are positive. But whenever the C term is negative, right? One term, one of the binomials is positive, and one of them is negative. All right. And then we just have to figure out the number that's going to go inside, right? Now I have a 9 on in that last term, right? So there's a couple of ways we can get 9. 3 times 3 or 1 times 9. Well, how am I going to tell which one it is? I'm going to look at the b term, right? Just off the top of our head, 3 plus 3 we know is 6, right? 6 is not 8, so that's not it. But 9 and 1, I could get 9 and 1 if I do, excuse me, let me say that again. I can get 8 from 9 and 1 if I subtract 1 from 8, right? So boom, so I already know what's going to go here, right? My two options are 9 or 1. But which one is it going to be, the negative or the positive? How do I know? The sign of your b term, the sign of your b term is the sign of the larger number. This is the 9, and then this is the 1. Let me just make that look like a number. And that's it. That's the whole answer right there. And that's how you think through the answer. All right. Is there any questions on this? The sign of the larger factor, right? Always. All right. If there's no questions on this, would you guys like to try one? Nothing crazy. I'll give y'all an easy one. This homework was posted already, the trinomial factoring. So same thing, right? You have a square term, my fault. I'll make it bigger. You have a square term, right? In the beginning and a square term at the end. So you know that you need two of those.
Wait.
Right? Two A's and two B's to get this answer. We just have to figure out the numbers and the sign of the numbers in the middle. So I'll give y'all like a minute. Y'all can try that. Mm-hmm. 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 Everybody good? All right, let's try this out, right? So again, this is going to be two binomial terms being multiplied together to get this quadratic term. I have a squared here, so that means it's going to be an a here and an a here. I have b squared over here, so there's going to be a b over here and a b over here. Simple, right? Now, I have to figure out, right, the numbers that's going to go inside these. So I have a positive 10 here. If my C term is positive, that means that either both my terms are positive or both my terms are negative. But how do I know that? I have to look at how do I know which one it's going to be? Excuse me. I have to look at the B term. So the B term here is negative. So I know that both of these are going to be negative. Easy, right? Now, there's a couple of ways I can get a 10 from multiplication. 5 and 2 or 1 and 10, right? Now, if I take 5 and 2 and I add them together, that's 7. 7 is not 11, right? But if I take 10 and 1 and I add them together, right? That's 11. Since they both negative, it don't matter which way I put them, right? So 10, 1. That's the end of it. It's a 1, by the way, not a dash.
So it has to be a number that adding up gives me one term.
Gives you the B term, right? The 11 is the B term, yeah. Just to recap, right? This is ax squared plus bx plus c, right? So when I say b term, that's the middle term that's next to the x. When I say a term, I mean that's the coefficient of the x squared, and the c term is just that number on the end, right?
That would be 11.
Mm-hmm. Yeah. You all right, Lauren? All right. Okay, good, good, good. All right. All right, I'm gonna give y'all like 2 minutes to try this next one. Nothing crazy. You got a U and a V, right? All right, let's take a look, right? So we know that our factors are going to be two binomials being multiplied to one another, right? This is a u squared, so we're going to have a u here and a u here. This is a v squared, right? So we're going to have a v here and a v here, all right? Now, I just got to figure out two numbers that multiply to negative 12 and add up to negative 9, right? So the 12 is negative. So what does that tell me? That means that one of these are going to be positive and one is going to be negative, right? We just have to figure out the combination. So let's look at this. How many ways can we get a multiple of 12, right? So we have 1 in 12, right? So sorry, 1 in 12, right? So if I were to subtract 1 in 12, I don't get 9, so that can't be it. Let's try 2 and 6. If I subtract 2 and 6, that's 4, that's not 9. All right, let's keep it going. What about 3 and 4? If I subtract 3 and 4, that's 7. No, that's 1, excuse me. Right? That doesn't work either, right? So what this goes to show you is that not all quadratics can be factored. This is the answer. All right. Go ahead. Go ahead.
So it's nothing.
It's nothing. Yeah.
Because you can't factor, so it stays the same.
Exactly. Yeah. What's up, Warren? Yeah. Huh? Yeah. Yeah. Exactly. Exactly. Yeah. All right. Let's try something else. I'll give you guys a minute to try this. Okay. It might look different, but it's the same thing. Appreciate it. Oh, that's yours. Keep it. So where do we get this? All right, so here's the first thing we got to do, right? We got to look for our greatest common factor. So what does each one of these terms have in common? They all have x. Very good. What else? And then multiplied by 4, right? So 4x, right? So anytime you factor out a 4x, remember, it's like you're dividing by 4x, like you're dividing by 4x, like you're dividing by 4x, right? So 4x cubed divided by 4x is what? Exactly, x squared. And then 16x squared divided by 4x is what? 4 what? No, 4 times. You're almost there. No.
That's what it's.
So 16 divided by 4, that's 4. And then x squared divided by x is x, right? That's it, so 4x. And then now we have our negative. 20 divided by 4 is 5, right? And then the x's just cancel out. Good. So now you can go a step further. We have 4x. You already know this is going to be two binomial terms. This is an x squared, so there's going to be an x here and an x here. This is a negative 5, right? So what does that mean? It's a negative term. One's going to be positive, one's going to be negative. Now give me two numbers that multiply to give me 5. 5 and 1, right? Now the b term here is positive. So where am I going to put the 5? Where am I going to put the 1? All right, five positive, 1 negative. And I'm done. This is my answer. That's it. Sure. Questions about this? All right. Yeah, take your time. Take your time. Do you guys want to try one or you feel good about this? You can try one. All right. I feel like this next example might pop just a little bit more than this one. I'll put it back 1 second. I just want to blow this up. All right. You guys want to see that? Good. All right, try this out. Warren. Warren. You okay? You okay? You want to talk?
Oh.
So we good? So what should we do first here? Five what? Very good, all right? So it's like I'm dividing by 5x. I'm factoring out 5x. I'm dividing by 5x, right? And what's left over? So 5x cubed divided by 5x is very good. Plus 3x, very good.
Plus 1.
Minus 4. Yep. So now you already know my final answer is going to look something like this. It's going to be two binomials we multiply to each other. This is an x squared, so you know there's going to be an x in the beginning and an x in the beginning. Here's the hard part, right? My c term here is negative, so I know that one is positive and one is negative. Now I need two numbers that multiply to give me 4, but they have to add up to 3. Or subtract the 3, actually. That's a better way of saying it. So is it 2 and 2? Is it?
Yeah.
It is? All right. So which one do I do? 2 plus 2 is, or no, 2 minus 2 is what?
22.
Yeah. I need it to be 3 though.
Oh.
So what else could it be? Two numbers that multiply to give you 4.
Oh,
4 times 1, right? Now, where am I going to put the 4 and where am I going to put the 1?
let's do the 1 first.
It doesn't matter. But which one is positive, which one is negative? The 4 or the 1? Which one? Is the 4 is what?
Positive.
It's positive? Okay. How'd you know that?
Okay.
The b term. The sign of your b term is the sign of the larger number. All right? The b term.
I'm not going to the beginning. I had that in the back of my head, but I forgot how to say it. So,
Gotcha.
yeah.
All right, but that's it.
Okay, I did it.
All right. Questions on this? Anybody? You good? All right, let's keep it going. So I'm going to introduce a new idea to you guys. This is called the AC method. You might have heard about this one before. Maybe. Me personally, I didn't hear about it till I came to BCC. I was blown away. I'm like, AC method, what's that? So look, every quadratic term is of the form ax squared plus bx plus c, right? So whenever I say the AC method, right, what am I going to do? I'm going to take my A and I'm going to multiply it times C, right? In this case, what's my A and what's my B and what's my C, right? So my A is the number that's next to the x squared term. So that's going to be 6. My B is the number that's next to the x term. So that's going to be 7. And my C is the number that's just all by itself at the end, right? Now, when I say AC method, I'm going to first do A times C. So in this case, that's what? That's 6 times 2, which is 12, right? And my B term is 7, right? So now I want to figure out two numbers that when I multiply them together will give me a 12, but when I add them together will give me a 7. What are they? 4 and 3? All right, let's try it out. So 4 times 3 is 12, and 4 plus 3 is 7. That's excellent. Now, check this out. This is how I factor with this. So I'm going to rewrite my question. So I have 6x squared. But instead of using the 7x, I'm going to use the numbers that we found. So this is going to be plus 4x, plus 3x, and then plus 2. So I'm replacing the 7x with the 4x and the 3x in the middle. All right. And also, it doesn't matter which order that you write these in. If you write the 3x first and the 4x second, that's fine. The order doesn't matter, right? But now look at how many terms I have. 1, 2, 3, 4. So now I'm back to factor by grouping, right? So we group them, right? Remember how we do that? We just split them in two. On my left-hand side, I have 6x squared plus 4x. What's the greatest common factor here for 6x squared plus 4x? What do they both have in common? 2 and what else? 2x. Perfect, right? So remember, whenever you factor out a 2x, it's like you're dividing by 2x. It's like you're dividing by 2x, right? So 6x squared divided by 2x is what? 3x, right? And 4x divided by 2x is 2. Perfect. Now over here, right, I have a positive 3x and a positive 2. What do they both have in common? What number? 1, right? Plus 1. So now remember, when you factor out a 1, it's like you're dividing by 1. It's like you're dividing by 1, right? And you know, anything divided by 1 is itself, right? So this is just 3x plus 2. Now, greatest common factor, right? What do these two terms have in common? The parentheses, right? The 3x plus 2. So I'm factoring out a 3x plus 2, my binomial term. Remember, when you factor out a 3x plus 2, it's like you're dividing by 3x plus 2. It's like you're dividing by 3x plus 2, right? These will cancel, leaving back what's left on the outside, the 2x plus 1. Perfect. This is my answer. And that's how you do the AC method. Right? Not too bad, right? You want to try one? All right, go ahead, go ahead. Want me to scroll up or you good? All right, go ahead. And this is the bottom part right here. All right, try this out. Remember what you're supposed to do before you start the problem. What are you always supposed to look for first? All right, let's check this out. What should I do first when I'm doing this question? I should look for the what?
The AC.
Even before that. Starts with a G. Right. So what do they have in common here? Both.
The Y.
So this one doesn't have a y, so it's not y. So it's the numbers. What number do they all have in common? 5, right? So what am I going to do first? I'm going to factor out of 5. So remember, when you factor out of 5, it's like you're dividing by 5. It's like you're dividing by 5. It's like you're dividing by 5. 10y squared divided by 5 is what? 10y squared divided by 5. 2y squared, right? Minus 55y divided by 5 is 11y. Very good. And then plus, what's 70 divided by 5? $14. Perfect. And that's it. So now let's do our AC method, right? What's my A in this case? The 2, right? The coefficient, the number that's in front. What's my B? What is it? Close. Give me a better answer. Close. Give me a better answer. Not just 11, it's what? Negative 11, right? And then C is what? 14, right? So now we want to do our AC method. So A times C, in this case, is what? 2 times 14, which is 28. Very good, right? Now, here's what I want. And my B is equal to negative 11. I want two numbers that when I multiply them together will give me a 28, but when I add them together will give me a negative 11. What are they? Right? So is it negative 1 times negative 28? That gives me positive 28. But negative 1 plus negative 28, that's a negative 29. That doesn't work. What else can I try? So I heard a negative 4 and what? And negative 7. Okay. So 7, 4. Yep, that's a positive 28. Let me see. Negative 4 plus negative 7. Let me see what that is. I think that's negative 11. Perfect. That's it. Right? So you can go down this process, right? If I didn't know what it was, I would have started off with negative 1 times negative 28. Then I would have done negative 2 times 14. Then I would have gone to 3 if possible. If not, the 4 times 7, right? So on and so forth until I get the right answer, right? All right, let's rewrite what we have. So I have 2y squared, but instead of the negative 11y, I'm going to write negative 4y minus 7y plus 14. Right? Again, it doesn't matter the order that you write the two middle terms in. If you want to write the negative 7y first and the negative 4y second, go ahead. No problem. It doesn't matter. All right. So now I have 1, 2, 3, 4 terms, right? So I'm going to go into factor by grouping. So I'm going to split them down the middle. On my left-hand side, what do I have in common? What do they have in common? 2 what? 2y, right? So remember, if I'm factoring out a 2y, it's like I'm dividing by 2y. It's like I'm dividing by 2y. 2y squared divided by 2y is y. Very good. And negative 4y divided by positive 2y is negative 2. Very good. Not the y. The y is canceled, right? I'm looking at my second term. I have negative 7y plus 14. What do they both have in common? 7. Good. Give me a better answer. Negative 7. How'd you know that? Is there? All right. Remember, the sign of your leading coefficient is always a sign of your factor, right? So I have negative 7y plus 14. My leading coefficient is negative, so my factor is negative, right? And remember, it's like you're dividing by -7. All right. So -7 cancels out, leaving back y. Positive 14 divided by -7 is what? -2. All right. And that's it. So now, greatest common factor. All right. What do these both have in common? Both terms have y minus 2, right? So I'm going to factor out a y minus 2. And what's left over? 2y minus 7, right? Very good. So 2y minus 7. That's it. This is my final answer. Right? Not bad, right? Any questions on this? Good. Oh, not gonna lie, that one was a little bit harder. All right. So here's the deal, right? I just showed y'all like the magic sauce, right? Like this is how you could factor any trinomial that you need to, right? What I'm about to show you right now is a trick, right? You can remember it if you want to, or you can not listen to it and just continue doing this, and you'll always get the right answer. Your choice. But I'm going to show you guys a trick right now. All right. So here's your trick. This is called factoring special products. All right. More specifically, we're factoring a perfect square trinomial. This does not work on all trinomials. This only works on a special trinomial called a perfect square trinomial. All right. So here it is. If a and b are real numbers, then a squared plus 2ab plus b squared is equal to a plus b squared, and a squared minus 2ab plus b squared is equal to a minus b squared. So here's how to factor a perfect square trinomial. Some trinomials are perfect squares. They result from multiplying a binomial times itself. So we squared a binomial using the binomial squares pattern in the previous chapter. So look, remember when we had a plus b? So this is like, let's say we had 3x plus 4. If you multiply it by itself, it comes out to be what? 3x squared plus 2ab plus b squared. Put it all together, it's 9x squared plus 24x plus 16, right? The trinomial 9x squared plus 24x plus 16 is called a perfect square trinomial, and it is the square of the binomial 3x plus 4. All right. So what I was saying before, which is still an option right now, they're telling you that 3x plus 4 squared equals that. Remember that 3x plus 4 is just 3x plus 4 times 3x plus 4. You can FOIL it, right? And you'll come out to the 9x squared plus 24x plus 16, right? Remember though, I'm talking about factoring, right? So I'm not actually interested in multiplying this out. I want the reverse. I want to go from the perfect square trinomial to the factors itself, right? So there's a shortcut, and this is a shortcut right up here, right? So if I have two positive numbers being added together, 3x plus 4, for example, you just plug it into this formula here. A squared plus 2ab plus b squared, and boom, that's the trinomial, right? Vice versa. It's there somewhere. Yeah. Let's try it out. Let me kind of show you guys this one, and then you guys can try one after. So this is a perfect square trinomial. I have 9x squared plus 12x plus 4. All right. For 9x squared, you know that that's just what? 3x squared, right? Plus, and by the way, I'm getting this from the formula a plus b squared is equal to a squared plus 2ab plus b squared, right? So my a term is just 3x squared plus 2 times my a, which is 3x. And I don't know what my b is, but let's look at it, right? How can I get 4? 4 is just what? 2 times 2. So this is 2 squared. So this is here too, right? This is a, 2, a, b, and this is the b squared, right? So what is the factor going to be? What is the factor going to be, right? This is going to be, hold on, forgot the square right there, right? This is going to be what? The a term, right? Which is 3x plus, the plus comes from here, right? Plus the b term, which is 2 squared. This is the answer. And I'm done. All right. Again, it's a trick, right? It only works with a perfect square trinomial. Memorize it if you want to. If not, you can just use the AC method, and that works for all questions. All right? Your choice. And by the way, if the B term right here was negative, this would have been a minus sign in the middle. That's the difference between the two formulas. All right. Let's make a little note. So the sign of the middle term, right, determines which pattern we will use. When the middle term is negative, we use the a squared minus 2ab plus b squared formula, which factors to the a minus b squared. All right. Let's try it out. So let's try this one out. Now your b term here is negative, so you already know you're going to use the other formula. Just to give y'all a hint, you have the a squared minus 2ab plus b squared formula, which corresponds to the a minus b squared. All right. We good? All right, let's break this down. So I have 81y squared. That's going to be what? 9 y squared. That's how I get the 81y squared. Minus the 2 times the a, which is 9y, times the b, which I'm not really sure about. So let me just do the b real quick. 16, which is just 4 squared. So I'm going to write 4 right here. There we go. And you know that this is corresponding to what? The a, which is 9y, minus the b, which is 4, and then squared. This is my answer. Any questions on this? Again, it's just a trick. If you don't want to memorize it, that's fine. You have your AC method, it will always work. Mhm. Another question. Give you guys a minute to answer this. Same thing though, just factor. This is that double variable kind of question. So remember how this special factor will look? All right, let's take a look. All right. So again, perfect square trinomial, no factors here. So this is what? 36x squared is just 6x and then squared. This is plus 2 times the 6x, right? Now we got to get our b term, but I don't know what that is. This is 49y squared, so that should be 7y squared. So put a 7y right here. And that's it. And remember that this is corresponding to what? Right? This is going to be the a plus b. So this is just 6x plus 7y squared. Questions on this? Good. The big difference here is that there's a variable in the b term, you know? Let's try another one.
It'll work.
Okay. Yeah. Appreciate you. All right, so try this one out. Now, technically speaking, this isn't a perfect square yet, but there's something that we could do to it to make it a perfect square. Right? Something we did in an earlier problem. Starts with a G. Oh my gosh, I forgot to say this in class earlier, right? So about this Thursday, right? You know, usually tutoring is 12 to 6, right? There's actually going to be a training that day, so tutoring is not going to start until 2 p.m. on this Thursday, all right? So if you guys want to come in, it'll be from 2 to 6, and then we have class at 6. There you go. I'm sorry. So there's a training happening on this Thursday. So tutoring is not gonna open until 2 p.m. on Thursday. Yeah, usually it's at 12, but now it's gonna be 2 p.m. That's just for this Thursday, by the way. That's not like going forward or anything like that. Got it? Well, tell me what to do first. What should I do?
Okay, so the first term, I need to find the number that square keeps me 100, so 10 is the compound.
Before that, I should look for what? It starts with a G.
Where is coming from?
Right. What do they have in common?
4
4, good. And what else?
and 10.
Not 10. 4 and there's a letter there that they have in common. Not X,
Only X.
Y, right?
Oh, it's
Yeah. So now remember, it's like we're dividing by 4y. It's like we're dividing by 4y. It's like we're dividing by 4y, right? So what's left over? 100x squared y divided by 4y is what?
the next one.
Close. Give me a better answer. Close. Give me a better answer. What's 100 divided by 4? Not 10. 100 divided by 4. Not 10. 25, right? This is 25x squared, right? Minus, what's 80 divided by 4? What is it? 20, right? So this is 20x, right? Because the y's cancel out. And this is a hard one, right? What is 16 divided by 4? Very good. All right. Now we have a more manageable perfect square trinomial, right? So this is going to be 4y. There's going to be something squared, right? So what's my a term here? What is this? This is what? 5 what? 5x squared, right? So that's my a term, 5x. This is negative, right? Bring down the negative. And then what is the 4? Give me two numbers that multiply, give me 4. So this is 2 squared, right? So that's my b term. This is my final answer. Not bad, right? I could have done the middle part too, but you get the idea. Again, it's just a trick. If you don't like it, it's okay. Use the AC method. The AC method will always work. All right. I have one last thing I want to show you guys. This is probably going to be the easiest thing ever. All right. Just to recap. So we spoke about how to factor when we have four terms, right? We use the grouping method, right? Three terms, we're using the AC method or this special um, perfect square trinomial thing. If you want to, your choice. Now I want to talk about what happens when we have two terms, right? So we spoke about four or more, went down to three. Now we're gonna do two. All right. So for two terms, this is called the difference of squares pattern. Right? So if A and B are real numbers, right? We're gonna have A squared minus B squared. That's gonna be equal to A minus B times A plus B, right? The difference of two perfect squares, difference means subtraction, right? A squared minus B squared is just gonna be conjugates, A minus B times A plus B. That's it. Real simple. Let's take a look at an example real quick. If we were multiplying this, for example, say I had 3 minus 4 times 3 plus 4, right? I would just FOIL that out and I would come back to a squared minus b squared, which is 3x squared minus 4 squared, or 9x squared minus 16. Again, this is factoring, right? So I want to go in reverse. I want to go from the 9x squared minus 16 up to the 3x minus 4 times 3x plus 4, right? And we use this pattern right here. If we have a difference of two perfect squares, difference means subtraction. The factors are going to be one positive and one negative, conjugates of each other. All right? Let's try this out. So look at this example here. I have 64 y squared minus 1. Now you already know this is 64 y squared. This is just what? This is just 8y squared, right? Minus the 1 squared. That's the difference of these two perfect squares. So what's my answer going to be? It's going to be a binomial, right? My A term is 8y. My B term is the 1, right? One of the answers is positive, one of the answers is negative. I'm done. That's it. That's the difference of two perfect squares. Questions on this? Let's break it up and that's it. I'm gonna let you guys try one. All right. For your homework, make sure you use those parentheses as well. That'll help you in the answer. We good? All right. This is it's speaking right now. Oh man. All right. This is 121 m squared, right? We know that this is 11m squared minus
The one.
the 1 squared, right? So this is the difference of two perfect squares, right? So you already know this is going to be two binomials. Your A term is the 11m. Your B term is the 1. One answer is positive, one answer is negative. Doesn't matter which one you call positive or negative, and that's it. Questions on this? No? All right, let's keep moving. Same type of question as before. This time I got a double variable. So you know that means that I'm going to have a variable in my A term and my B term. All right, we'll try that out. So difference, one positive, one minus. That's all. All right, let's try this out. So you already know, right? My A term, this is going to be what? 12x just squared, right? Minus my B term, this is what? 7y and squared, right? So you know that this is the difference of two perfect squares. So my A term is going to be here and here. My B term will be here and here. One is positive, one is negative. Doesn't matter which one you call positive or negative. That's it. Questions on this? Anybody? Good? All right. I think we might got to do this one together. So I was looking at it and I'm like, oh man, I don't even know how to do this. But y'all know y'all timetable, so y'all can help me out. Mhm. So what should I do first? What do we think? Greatest common factor, right? What do you guys think the greatest common factor here is? What do both numbers have in common?
30.
Good. How you know that?
Oh, right.
Yeah.
Oh, I think some guys.
Right. So this is how I knew it was right, right? If you add up all the numbers right here, right? So like 2 plus 4 plus 3, that would give you what, like 9, right? 9 is divisible by 3, so this is divisible by 3. And if you add 4 plus 8, that's like what, 12 or something? 12 is divisible by 3, so this is divisible by 3. All right. What else do they have in common? Yeah. Yeah. I'm just filled with tricks, you know? So what else do they have in common? Both terms have y squared. Very good. Right? It's like I'm dividing by that, right? So let's do the first one. 48 divided by 3 is what? 16. Very good, right? 16x to the fourth minus what is 243 divided by 3? 81. And then y squared, you already know cancels out. Bam. Not too bad, right? Same thing as before. You already know this is what? 4x what? Squared. Very good. And then that's squared right there, right? Minus what? 9 squared. Very good. All right. That's the trick right there. So that's my final answer. All right. You already know. This is going to be 4x squared. 4x squared. This is going to be 9. This is going to be 9. One positive, one negative. Right? Everybody got that answer? No? All right. Am I done? All right. What else can I do?
The 4 can become a 2.
Exactly. Exactly.
The 9.
Exactly. Right. So this is like 2x squared. And then this one is like 3 squared, right? So my final answer is 3y squared times 4x squared plus 9 times 2x minus 3 times 2x plus 3. This whole thing is my final answer. All right. Questions on this? All right. Sometimes we got to keep going with it. All right. I know we only got a couple minutes left, but so you might not have time to copy this, so you might want to take a picture. Um, just want to kind of sum up Wednesday and today a little bit. This is what's called the general strategy for factoring polynomials. All right. So check this out. Always you start off with the GCF, right? No matter what, you see an expression in front of you, first thought, GCF. Does it have a GCF? If it does, right, factor out the GCF and then factor accordingly. If it doesn't, that's okay. We just go back to factoring accordingly. Now you have three options here, right? You have binomial, trinomial, and more than three terms, right? So let's go from right to left. When you have more than three terms, right, you do factor by grouping. That's when we split it down the middle, greatest common factor on the left, greatest common factor on the right, what's left over, boom, 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 right? When you have three terms, that's called a trinomial, right? So three terms, right? Now, if you have just x squared plus bx plus c, your factors are going to look like this, x, and then you just have to figure out two numbers that multiply to give you c but add up to the b term. When you have a number in front of the x squared term, you use the AC method, right? The AC method. If this is too much information, and you want me to make it real simple for you, all right? Just remember the AC method and do that for every single question. You're done. It'll work for every single question, all right? Even though I showed y'all a whole bunch of tricks, that one method works for all questions, all right? Now, let's say that we have two terms, right? That's a binomial. Then we have the difference of squares, right? Difference of two perfect squares. That's what we just practiced. A minus B times A plus B. One factor is a positive, one factor is a negative. That's it, right? If you have what's called the sum of two squares, the sum of two squares, like this part right here, right? The 4x squared plus 9. That's the sum of two perfect squares. You cannot factor that. You're done, right? That stays the same, right? Only the difference with the minus can be factored, all right? And then don't worry about the sum of cubes. We're not going to talk about that or the difference of cubes, right? After the class is over, if y'all want to talk about it, come back and we'll talk about that, all right? But that's it. And no, you won't need no sum of cubes for math 30 or nothing like that. You're welcome. Questions? Anybody? Good? All right, just come up and sign the attendance before you leave. There you go. Can I take this down? This one? Appreciate y'all. Thank you.